Hello everyone, I'm Ashok, and today's topic is ROC and AUC score. ROC stands for receiver operating characteristic, and AUC area under the curve. And these are very important metrics for binary classification. To understand the purpose of this, let's first take an example, understand the binary classification itself, and then we will go into ROC and AUC. So I'm going to use one of the standard data sets, breast cancer data sets from UCI repository. Importing pandas, data is equal to read CSV, breast cancer data set. Now let me print the shape of it and then head. So this has 30 columns as a predictors, and the last one is outcome. Outcome 1 means diagnosed with cancer, malign, and 0 is no cancer, which is benign case. Okay. So for this example, I'm not gonna use all the 30 columns as my predictors. I'll be using only one column for simplicity's sake. So I'm going to say X is equal to data ILOC, all the records, only the first column. Y is equal to data outcome. Okay, so that's my X, and Y would be, let me also look at the shape of the X. Yes, pretty good. Y is your outcome. All right, great. So let me quickly spare me a minute. I'm going to quickly build a logistic regression model. So for that, I need to first of all, let me first split the data set. Model selection, import train test split, and I'm going to say X train, X test, Y train, Y test is equal to train test split, X comma Y. I'm going to put a test size as 0.3 and random state, as I always put, I'll put some 10. Great. And then I'm going to import logistic regression model. It's in your linear model package. Import logistic regression and say model is equal to logistic. I'm not going to do any fine tuning here, so the purpose is not modeling. Say fitting X train, Y train, and I'm going to predict is equal to model.predict X test. So training and prediction is done. Ignore that warning. It's a future warning that a default solver is being replaced with LBFGS in next version. So evaluation from metrics, import. I'm going to import accuracy score. I say accuracy score. I can print that accuracy score. So Y test, Y predict. Okay, and PD cross tab, Y test, Y predict. Great. So we have about 90% accuracy with just a single variable. If you actually take all the variables, you will reach close to 100%, 99% accuracy. But this is if you really look at this is confusion matrix. I'm going to explain it on a very high level. I have a complete video on confusion matrix. You can search in the same channel, confusion matrix, and that explains confusion matrix in much more detail. So for now, I'm going to take a quick explanation. This is actual and this is predicted. Okay, so there are 108 108 records which are actually no cancer or benign, predicted as no cancer. These are all true negatives. And this 45 is cancer being predicted as cancer. We call it as true positive. And this 4 or non-cancer being predicted as cancer. This is called as false positive. These guys, it's not very dangerous because further test might really reveal that they don't have a cancer. So this is still fine. Take this one, false negative. This is dangerous because these are cancer patients being predicted as non-cancer. So basically, they will not take the treatment, and that's a very dangerous situation. Ideally, in this case, I want to reduce my false negative to 0. Okay, but if you really see how this has been classified, I can take a help of logistic regression if it's a sigmoid curve, S curve. All right. So in this S curve, let's say, so this is your one level probability, and this is 0, and this is nothing but your outcome. Logistic regression actually gives you a continuous probability value, which is fitted like S curve. So I'm just going to roughly draw it. You can visualize this, but for now, okay. Something like this, okay, not being very accurate. So this is a place of ambiguity, and this is going to more towards the, okay. All right, and this is your mean radius. Mean radius, let me just look at the range of it. I don't know about that. Okay, so let me look at the minimum value and the maximum value. Okay, that's good enough. About 6 and 28, 7 and 28. So let's say somewhere around 15. So let's assume that it's a big graph, and this is about 15. This is about 16. Somewhere here there is a lot of confusion, and the probability is little ambiguous over here. This is clear. It's going towards a positive, and this part is more towards the 0. So that's also clear. So generally, what we do, a default threshold for logistic regression is your 0.5. If the predicted probability is above 0.5, we simply call it as positive. And if the predicted probability is below 0.5, we call it as below or equal to 0.5, we call it as 0 or negative. Okay. So in our case, what happened is there are about 14 positives, okay, which were classified as negatives, predicted as negatives. So probably these 14 actually lie over here. I'll take a different color for this. So these are actually positives, but because it is being mapped to here, the probabilities are actually coming under 0.5. If you look at the probabilities, they're coming under 0.5. I don't know, 0.4, 0.3, 0.35, 0.3, and stuff like that. So it's because it's coming in this region, less than 0.5 probability, it's predicted as 0, which is all wrong predictions. We also have 4 wrong predictions in false positive, which is wrong predictions over here. Maybe somewhere here as well, we don't know. So these are actually negatives or non-cancer people being predicted as cancer. Okay. Now these are all wrong predictions. Apart from that, you might have many other values over here and many other values over here, which are correctly predicted. So these are all your true negatives and true positives. True negatives are this section. All of these belong to true negative, and all of these belong to true positive. all of these belong to, they were actually positive but predicted as negative. So these are false negative, 14 of them here. Okay, and these are all are four of them, they are actually negative being predicted as positive. For us, this is dangerous. This is bad. This is bad because these are actually cancer patients being predicted as non-cancer because it's actually falling under this region of your curve. So hope that gives a perspective of what we are dealing with. Okay. So I want to make this false negative as ideally zero because I don't want any of the cancer patient being predicted as non-cancer. Why? Well, they don't get the treatment and it's very dangerous. So that's possible if I can shift this line. This is called as threshold actually. The default threshold is 0.5 in logistic regression. If you can shift the line below, let's say I make a threshold 0.2 or 0.3, okay, somewhere here. Let's say 0.2, 0.3, maybe 0.2. Okay, what happens? All of the okay, let me just make it a little better. I'm gonna take these green things here because that's interfering. This graph is really not to the scale, as you could understand. So I'm just trying to create. Okay, and only there are four of these things. Okay, good. So if I can create a graph at a threshold of somewhere here, what happens is all of your false positives, actually all of the cancer patients will be now predicted as cancer because my threshold has moved down. Any prediction coming in this region will be predicted as 0 and above will be predicted as 1. So thereby we can bring in our false negative to 0. But how do you do that in Python? sklearn implementation? Well, the predict function actually has 0.5 threshold fixed and there is no parameters, as I know we can use it to change the threshold. But it also has another function called predict prober. Almost all your classification algorithms have it. So predict prober will give you both the probability of being non-cancer, which is the 0, 1, and probability of being the cancer, which is the 1. Both of these were actually given as probabilities. So I can actually take the second one, this one. Oh, okay. So I'm going to say okay, so this is the second one of it. So this is the probability of having a cancer. Okay, so I can use this probability and basically change the threshold. So something like this, I can write a statement with a numpy where function. Let me import the numpy has np. So I can say np.where, okay, and say model dot, let me copy paste this one. Okay, if it is greater than 0.3, for example, okay, then I call it as 1, otherwise 0. This will give you a prediction where threshold is 0.3. Simply the threshold is 0.3. Great. So with one statement, we could actually simulate the scenario. Likewise, if you want to, look at the threshold of, okay, you can actually store this into a predicted file. Let's say predict, why predict? I will say threshold is actually 0.3. So I'll put 3 here. Okay, just for quick understanding. And then I can also do threshold 4 0.4. And when I'm looking at my confusion matrix now, let me copy paste the confusion matrix code over here. So rather than putting predict, I'm going to say threshold 3 and see. So you see that almost a lot of variables from here, a lot of mispredictions, which is no, still not 0 yet. So there were 14 cancer patients being predicted as non-cancer, cancer being predicted as non-cancer. Now it has reduced to 5, but at the cost of the other side, which is actually, this false positive has increased. False positives are still fine. If you put threshold 4, this is still 10. The 10 is a big number. Okay. So I want to see for all the different values, right? You can do it manually like this, or you can write a for loop, or even you can write a function. So I'm going to write a function. So I'm going to write a function like definition, and I'll say predict with threshold, for example. I can write a shorter name, of course. I'll give the model. I give x test, and then I'll give thresholds. Okay, thresholds basically. And inside that, I will take this entire thing. Okay, I'll put it, and in here I'll simply say thresholds, and I can return this. That's all. Only one statement. So if I pass on the model value and the x test and then the thresholds, it automatically gives it. Now I'm going to write a for loop, and for loop threshold, I would say thr in, I want a range of threshold from 0.1 to 0.9. I can use np itself. Okay, np is not defined. Even here I have to define np, otherwise it will throw an error. Okay, let me run that. And np a range, I'm going to take from 0.1 to 1.0 entire thing, or maybe from 0 to, you can do that as well, 0 to 1.0. I'm going to say y predict is equal to predict threshold, which is my function. Then I'll pass on the model, and I pass on the x test, and then I pass on my thresh. Okay, then I'm going to print confusion matrix. Let me also import the confusion matrix from sklearn matrix, import confusion matrix. Oh, sorry, I should say from confusion matrix. So I'm going to print confusion matrix y test and y predict, but y predict keeps on changing because it's basically looping through the function for getting the different threshold. You have different prediction. I also like to put threshold is equal to, just print the threshold, run it. If there no error, okay, it's only run once. Oh, I have to put a range. So let's say 0.1 is the increment, so it goes from 0 to 0.1, 0.2, 0.3, 0.4, 0.5 till the 1. So when the threshold is 0, everything will be positive, because just look at this one. If the threshold is 0, this is 0. Okay, anything comes in, it will be tagged as positive because everything will be above 0. So we will not have any negative predictions at all. All of things are actually positive. There are 59 true positives and 112 false positives. Okay, this 112 of the people who are actually, this is the one who are actually non-cancer being predicted as cancer. Threshold 0.1, we have 87, 0.2, 0.3. If you go to threshold 0.5, this is exactly same as your prediction. So if you look at our prediction, which is a default predict from logistic regression, this is exactly same as this one. So 14, 4, 108, 45, you have the same thing. Threshold 0.6, threshold 0.7, at threshold point 8, you see that, okay, this is not really good. In fact, only value we get 0 over here is threshold point 1, but you have a huge number on this side. So let's take all the 30 variables, have a more realistic prediction. Take all the variables except the last one, and then let's go through the entire thing. Okay, now you see that at 0.1 threshold, we have 0 false negatives, which are cancer being predicted as non-cancer. So this is a good model. Well, we do have a 23 who are non-cancer being predicted as cancer. In this use case, this is actually fine because that can be dealt. Well, this can be done by using in this method by actually looking at all of these thresholds, but it's very cumbersome, isn't it? Like, how do you really look at all of these and decide which is better? For this purpose, we have ROC and AUC curves score, or AUC score and ROC curves. Let me just explain them what they are. So the receiver operating curve, ROC, is essentially a graph between TPR and FPR. TPR stands for true positive rate, and of course FPR stands for true negative rate. Sorry, no, false positive rate. My apologies. Okay, so TPR is actually equal, like same as sensitivity. Sensitivity, yes, and also recall. So I'm pretty sure if you watched the previous video, we're talking about recall over there. The formula for recall or sensitivity or TPR, sensitivity is equal to true positive divided by true positive plus false negative. Okay. For specificity, okay, FPR is actually 1 minus specificity. So specificity formula okay, just a minute. Okay, specificity formula is Tn minus Tn plus Fp. But when I say 1 minus specificity, you're basically saying 1 minus Tn plus Fp, which is actually equal to, if you do the math, Fp divided by Fp plus Tn, which becomes your FPR, false positive rate. I'll write down the equations over here. FPR is actually 1 minus specificity, which is equal to Fp by Fp plus Tn, and TPR is nothing but recall, or also called as sensitivity, is equal to Tp by Tp plus Fn. So when your threshold is 0, if you look at your previous diagram, when the threshold is 0, okay, this is threshold being 0. Threshold is 0. Write it down over here. Threshold is equal to 0. Anything which comes in, any output, is obviously taken as positive, as 1, which means there won't be any negative at all, which essentially means that when threshold is 0, when threshold is equal to 0, both of your false negative and true negative will be equal to 0, because when threshold is 0, everything is predicted as positive. All right, which means when the Fn and Tn are 0, Tn 0, FPR becomes 1, because this becomes 0, this cancels, becomes 1. And again, if Fn is 0, Tp by Tp is also 1. So both of these, let's say this is 1 and this is 1 as well. this is 0. So both of this will be 1. So this is the point where your threshold is equal to 0. You take another extreme. Let's say your threshold is equal to 1. Threshold is equal to 1. What happens? Any value comes in as a prediction, any output prediction will be less than 1 because the range of your probability itself is 0 and 1. So everything will be negative. You can also see this in here. See, when threshold is equal to 0, your false true negative and false negative both are 0. Everything is positive. Again, if you look at threshold is equal to, I didn't have 1 here because I did not take that value. So let me just take 1.1 here. So obviously that you get 1 as well then. You see that when threshold is equal to 1, everything is negative. So either true negative or false negative. Your false positive and true positives are completely 0. So I can say that when threshold is equal to 1, both of your false positive and true positive is equal to 0, which means true positive 0, a recall or TPR becomes 0. False back to 0, FPR also becomes 0. So this is the point where your threshold is equal to 1. So when threshold is equal to 1, you get this point. When threshold is equal to 0, at this point. When you vary the threshold, okay, from 0 to 0.1, 0.2, 0.3, 0.4, you will be getting different points at different levels. And if you, it won't be like this, it will be something like this maybe usually. This is, let's say this is 0.1. And something like this. So if you join the lines, and this curve is called as receiver operating characteristics curve. And this is very important because you can visually see how is the threshold is affecting your true positive rate and false positive rate, thereby affecting your false positive and false negative, which of course impacts your recall and precision. Again, if you don't understand recall and precision, watch another video which I have recorded on confusion matrix, recall and precision. Great. So a very bad model might have a threshold like this. Sorry, the ROC curve like this, and a good model, which is almost like a one model, like you have 100% accuracy and no misprediction. So that will have this. So this is the best ROC graph, and this is like almost random. So you can take it as a bad model. This is a very bad model. All right, so that's ROC and AUC. We also have AUC, area under the score, under the curve. Well, you already know that this entire thing is a unit cube because 0, 1. So the area under this entire curve is equal to 1. So if you say AUC score is equal to 1.0, it means it's a perfect model. It has 100% accuracy, 100% recall, 100% precision, absolutely no misclassification anywhere. If you have this graph, let's say the bad one, you might land up getting AUC score, let's say 5.5 or 0.55 or something. So when you say AUC score 0.55, it's actually a bad model because it's randomly saying it's like 50-50. Whether it is true or cancer or not cancer, prediction is 50-50, then it's really not a good model. So this is the whole purpose of ROC and AUC score. So if we could also do that in Python. So let me show you how do you implement that in Python. So we have in metrics, sklearn, I don't fully remember, let me check. So I think in metrics, you have this ROC. Yeah, we do have ROC curve we have, and we also have ROC, AUC score. Excellent. So both of these are implemented in your scalar metrics. So let me find out ROC curve. First, I will see what is this ROC curve. Okay, of course I got an error, but I'll get a help. So what does it return? Returns FPR, TPR, and threshold. Excellent. So I'm going to pass on our, I'm going to say TPR. First is TPR, FPR, and thresholds is equal to ROC. I'll pass on the so true value and the score. Okay, score is predicted value. Okay, so I'm going to pass on the y test, which is y true in my case, and then y predict, but not the predict with which is actual. I will be passing predict, which is coming from the predict proba, this one, because that's when you get the grade. So is that all? Is there anything else I need to take care of? So position label, these are all not mandatory. Let me see if I get, yeah, I didn't get any error. Great. Oh, so this should be FPR. FPR. Okay, great. Let me also look at the thresholds. What are the thresholds it has taken? It has taken, it's taken 2, that's 0.96, 0.95, 0.77, 0.77, 0.73, 0.19, 0.15, and 0.11. Very nice. So let me write a quick matplotlib. All right, so I just did the basic plotting with limiting the x and y from 0 to 1, and put some title and x label, and then FPR, TPR just put a red color, and all of these values which I got from my ROC curve is being put in over here. So this is your ROC curve. So you can just basically this is being merged, and this is the one. I can make this line width a little bigger. Line width is equal to 3 maybe. Then you can see I will make it 5. So that's your ROC curve, and area under score is the area under this curve. So I think it will be about 98 or something. Let me check. So AUC score, ROC, AUC score. I'll pass on again these two things. It's 99.54. So it's only less than 0.5% is actually left over. So this is ROC AUC purpose, and it actually came to be more than 30 minutes video, but hope it's both. And I'm going to leave this on Git repository. I'll leave it on the comments in the description. So if you have any further questions on ROC AUC or any of these workings I've done, feel free to leave a comment, and I'll be more than happy to answer that. So thank you very much. If you like this channel, please subscribe and also click notification so that any further videos I upload, you will get a notification. I'll see you in the next video.